133 divides into your number, and this is the number, 11 to the n plus 2 plus 12 to the 2n plus 1. So how do I apply the idea of divisibility, idea of induction in a divisibility setting? And you'll see little different tricks here. So what? First step. 1. What's the step? N equals 0. So left side is 0. Oops, there's no left side. So what? It's not equal. It's about divisibility. Do you agree? So I have to reorganize it. So here is my expression. I'll call it expression E of n. So let me look at E of n. So how much is E of 0? And then I'll check if it's divisible. So how much is E of 0? 11 to the 0 plus 2 plus 12 to the 0 plus 1, which is what? 121 plus 12 equals 133. And it really works. I laughed for a moment the other day in my calculus for honors. I showed them one trick, and one of the students said, who sits and thinks of those things? You know, who thought that 11 and 12 combined like this will give 133? But generally, 4 generations and thousands of years, millions of people are trying all kinds of things. So they came up with little, interesting facts. All right. So is my number divisible by 133 at the level 0, yes or no? Yeah, so 133 divides my expression at the level 0. What's level 2a? Assume that for certain k greater or equal 0, 133 divides e of k. So my expression at level k is divisible by 133, which means, I don't know if I ever use this notation. It's often used in mathematics. I dot e. When you say the same thing, so it's nothing new. I didn't calculate, I just said it differently. It's a shorter from Latin idem est. Idem est, which is the same as. So 133 divides e of k, which actually means the same as 133 divides 11 to the k plus 2 plus 12 to the k plus 1. So assume divisibility is established at the level k. What do I need to do now? To establish it at the level k plus 1. Establish it for n equals k plus 1. So let me calculate e to the e of k plus 1. So what would that be? 11 k plus 1 plus 2 plus 12 to the 2 times k plus 1 plus 1. Now I did a little more careful than a minute ago. When you jump by 1, why will that give us 2k plus 3 at the end? So here is the expression, how it looks now. So what is this? Let me do the calculation, although I shouldn't, but doesn't matter. 11 to the k plus 3 plus 12 to the 2k plus 3. Here it is. And here is where things are now trickier than in previous examples. It's hard, or a little harder, to establish connection between this guy and this guy. Because this is where I know divisibility. So this guy, I know that this guy equals 133L. Do you agree? Because it's divisible by 133. It's equal 133L. But how can that influence this guy? That's a little tricky to see. Yes?
You split it up and then prove that it's divisible by what?
Oh, how do I split it up? Very good idea. So here it is. So first, I have here k plus 2. I have k plus 3. 11 times, exactly. But then, what do I do? 11 times k plus 2. Is everybody okay with that? But here comes the best trick. This guy would now like 144, but that's not good to separate, or maybe it is. Why not? So generally, what about this guy? He has 2k plus 3, and I would like to have 2k plus 1. So what should I do? Pull out 2. So it will be plus 12 squared times 12 to the 2k plus 1. So I made both of them look like they looked on the previous level. Unfortunately, there is one little problem. What is it? That I cannot split up the information from kth level. So here is the story. So I have the following: 11 times 11 to the k plus 2 plus 144 times 12 to the 2k plus 1. So I have the same two expressions as on the k level, but coefficients are not the same. But what happens then? What can I do? Can I split this 144 so that it becomes what? 11. And what's left? Exactly what we like. How much is that extra? How much do they differ by? 133. So I can write it like this. 11 times 11 to the k plus 2 plus 11 times 12 to the 2k plus 1. Why do I want both of them to have 11? So if I factor out 11 and call inductive hypothesis. But then there is extra, which is what? 133 times 12 to the 2k plus 1. And then what? Now this is, I can factor out 11. 11 to the k plus 2 plus 12 to the 2k plus 1 plus 133 times 12 to the 2k plus 1. Now, according to inductive hypothesis, this guy is equal to what? It's divisible by 133, so this is like 133L, and I can put 11 into L, so all this is 133L. And this one is 133 times 12 to the 2k plus 1. So what can I do now? So this was according to inductive hypothesis, because this one was assumed to be divisible by 133. And then what can I say? Can I factor out 133? Times L plus 12 to the 2k plus 1. And then by definition of divisibility, 133 divides my expression at the k plus 1 proved. We never use that notation. Quod erat demonstrandum. So you see, method of induction is always the same. What changes is connection between two levels depends what you are doing. With dots, it's usually cut and paste. With inequalities, again, you have to recognize your expression within a given one. Here, there is little kind of packing so that when they don't have the same coefficients, you separate apart. Hopefully, what if I got here 132? Probably it's not true, statement not true then. And I would build a counterexample because it shows that actually there's no good connection that would build things. So all these problems are made so that that really nicely appears and it works. Questions, comments? A little explanation of that? Is it like, is it the whole concept too complicated or all that changing the environment? Yeah, so, you know, this is methodology that's used all over mathematics. So we just gave you 3 examples. There are tons of them in calculus. Oh, by the way, what is the rule in calculus? What is derivative of x to the n? Can you prove this? What's say? But then you need some power. Try definition. you would need Newton binomial formula that we didn't do yet. So
prove that by induction.
yes, because what? If it's true, when n is 1, is it true at n equals 1, yes or no?
Yeah.
Assume that n equals k is true. Then when n is k plus 1, what do? X to the k plus 1 prime equals x to the k times x prime. Do you agree? Can I use the product rule? Yeah, so it's x to the k prime times x plus x to the k times x prime. Derivative of x to the k is kx to the k minus 1 times.
Reference the formula we're trying to prove.
What's a?
We
No, that's what I mentioned in the beginning of the class. I'm not referencing, I'm just saying at a certain level I established it. So I established it on first, second, so this may be seventh level. If you trust it on level 7, I'll show you how to get to 8. And then when you get to 8, I'll show you how to get to 9 and so on. So how much is this altogether? K plus 1, x to the k. So you just show if I can use it at the level k, then I can get it to the next level. And since I can do it on level 1, it will be true for every level. That's, by the way, one of the homework problems.
But that's assuming we know the definition of the derivative.
No, this is just assuming that you know product rule. Assume that you know product rule. So, by the way, even if in some other structure that are not real numbers, if you know the product rule, and you can have this derivative rule.